All right. December, we'll see if we get any of that white stuff known as snow. Hopefully.
What once known as snow. That Prince name, previously known as Prince, once known as snow. Yeah. Rain, once known as snow.
Nice.
Ye snow.
All right. So we're going to have updates from the policy and practice group, our normal stuff. It's going to be the year in review and a little bit of planning. Hopefully we'll get to that point to talk about 2024 and get questions, suggestions, etc. We are recording. I was noting we're getting quite a few views on the recording, so that's great to see. If people can't show up, they're at least able to use those recordings. So happy to see that. Recordings as usual at this location. Meetings will continue to be every third Thursday of the month, 2:30. Zoom link is the same. Feel free to share with others. I can put them on the reminder list, the email distribution list. If you've got others that would like to attend, feel free to share those individuals. Folks, just to review here, folks that are attending, this is a DRWI project associated with DRWI. We do have folks that are working in the DRB, plenty of folks working in the DRB that are attending these meetings that are not directly associated with the DRWI, and we've got sometimes some folks from outside the DRB attending. Currently supporting this work with Delaware River Watershed Initiative funds and Seesaw. DRWI, we're in our last year of it. 2024 will be the last year. You can check out the project there. Seesaw, we'll see about Seesaw for 2024. Again, meetings are just a time to check in. We provide updates on technology and whatever else has gone on. Generally have presentations in these meetings. Stroud team, me and Shannon and Krista. Krista's part-time, primarily she's works with the Musconetcong Watershed Association. Carol, Joe, and George and other master watershed stewards are a great support in this effort, as well as in the work group. John, Matt, and Dave, DRWI leads. Primary goal in this work, support station owners and users in doing what they want to do with their data. We're developing tools, providing these meetings, analyzing data in support of all that. Excuse me, I'll go into some updates now. There's an article coming out in Frontiers in Ecology and the Environment, Advancing Freshwater Science with Sensor Data Collected by Community Science. This is a Stroud Center publication. Lead author is Deanna. Scott and I are on that as well. Scott's on the call today. Scott's the assistant director at the Stroud Center. You'll be able to read that, but some kind of, main points here. Continuous data or complementary to USGS data. They're generally on much smaller streams than USGS stations are. So can be used complementary to that. Temperature and conductivity. This is stuff that we know experientially and through our own use of the data, that temperature and conductivity data are generally pretty reliable. Turbidity data, as we know from the original sensors, not so much. I'll mention the new turbidity sensor a little later that has been a little more functional, but there's also a section here that looks at different ways to kind of assemble these data into standard metrics to kind of help with understanding streams more broadly using these data. That should be coming out soon. We're kind of through fall now, or through the fall when there's leaves on the trees. So Battery issues should be resolving. Cycle batteries, if it still hasn't, talk to the Stroud Center, Shannon in particular, and me. If you need assistance with power supplies or anything, batteries, chargers, whatever. There is a supply list on the Wiki Watershed DRWI page. Or if if you think it's not a power issue or solar panel, whatever, feel free to be in touch. Snapshots, we're still continuing to support snapshots, primarily salt right now. So be in touch if you'd like to collaborate on that or receive assistance or support on that. I'm going to go through snapshot data here in a bit. Again, wanted to remind folks, if you want to share stories or anything through the Stroud Center social media, feel free to be in touch with Diane or me. Next month's presentation, at least tentatively, is going to be a review of technology, station management, troubleshooting, so on and so forth. This is, folks have been asking for kind of a workshop, another kind of station management workshop. So this is sort of an opportunity to kind of get at that type of information. I'm not sure. We possibly should have another just more focused and longer workshop to support folks in managing stations. Berks Nature is providing one for their organizations, their 4 umbrella organizations in March, I believe it is. There are some of those folks here today, but there may be a need for another one. So we'll see about that. Feel free to be in touch if you have ideas or want to host or something like that. Work group updates. Ian, do you want to
Sure.
provide those?
Yeah, I can jump in here. So currently this is the list of people who've been working for, I can't believe it, at this point it's been almost a year together to create these documents with the local policy practice work group. We meet the first Thursday of every month from 11 a.m. to 12:30. And throughout the process, we developed a short-term charge to guide us as we're creating these documents. And it's very focused on the types of data that our mayfly sensors collect, so that we can best communicate those to who needs to learn. And this is our short-term charge. I think we can move on. So the first document that is ready for use is the municipal interactions. It is a primer on how to engage best with municipal leaders, and we have gone through internal and external input on this document, and it is finally ready to be used. So we will be reaching out with ways on how to access that, and we'll touch a little bit more about that coming up here soon. The temperature document, it is in its last stages of internal review and starting external review. We have some one-pagers available for various parts of the temperature document, with some in development as well, though our focus has primarily shifted to the creation of the next guidance document of conductivity. And in this past meeting, we set up an outline for that and have started distributing various sections for that. So work is underway. So for putting stream temperature data to work, like I said, internal review is coming to conclusion and external reviewers have been identified. We have one-page summaries for single concepts, but also larger concepts throughout. And we're creating PowerPoint presentations for middle and high school curricular efforts in watershed ecology, which I think is more than what we set out to do initially, but I think is going to be a very helpful thing moving forward. And that first document, we decided as a group to host it via the Wiki Watershed link, and we can distribute a link to that for people who reach out, or you can go and find it yourself on the Wiki Watershed. Our partners are going to be able to access this, are free to distribute it, but we're going to try to keep it in one place. That way, since it's a live document, as it gets updated, everyone will have access to the most up-to-date version of whatever that may be. As more case studies come out, or as we fine-tune some of the language in that document. And then, Dave, do you want to talk a little bit more about the EAC network? Because I don't know much about this, but I think either Dave or even Tally might be able to talk more about
Dave or Tally.
Yeah.
I just received this and forwarded it to the work group. I think Carol actually you've been to these before, Carol?
Yeah, I think I've been to all of them except the first one. They have 2 every year. The spring is virtual statewide programs for EACs, and in the fall it's a regional in-person at Westchester University last fall get together. And I was noting to David that there are a lot of watershed and water quality advocates and scientists and presenters and attenders at these conferences. So there is a lot of relevance there, including how to work with municipalities. There was a very animated discussion last fall about that.
Carol or Ian or Dave or someone that I forwarded that to, would you mind pasting this link into the chat?
Yes, of
For
course.
anyone that might.
I can do that.
Thanks, Ian.
Okay, yeah, thanks, Ian, for that update. Any questions before we move on?
I have a question for Carol. That animated discussion, is there, were there recordings or separate elements that we could perhaps listen to, either audio or video of that?
So I'm sorry, there were just PDFs of people's slides. Yeah, it's the discussions came out of, interactions with the audience. John Jackson and I presented on local action to improve water quality. And there were, it was a full room and a lot of challenges about how you need to have very quantitatively based, well-established data if you're going to be trying to influence your watershed. So we haven't been that strongly worded in the document on working with municipalities, but we have been suggesting that all along the way in that document. So there is a need to do a footwork to prepare a presentation to your municipality. So anyway, I'm sorry, I went off on a tangent because
No,
that was one of the discussions we had there. Yeah, you need, and the other thing is you need consultants. There's a fellow there, and I just wish I don't remember his name right now. He's by trade a civil engineer who's now a township supervisor, who's really strong advocate on these issues. And you need someone to review plans and review your data. So anyway, that was just an issue too, how you might go about trying to find other people who would help you prepare your data.
I have one more. It sounds like it was a great meeting. Is there discussion in dealing with the municipal people to embrace a larger, how to look at the water in terms of climate issues? Or is it, in other words, hoping to nudge and bring municipalities along?
Right. Yeah, that's come up at various conferences. if you're interested in attending these, making use of We Can Serve PA's resources to provide these conferences to EACs, you should get in touch with them, let them know what your interests are, because before every conference, they put together a working committee to develop that conference. They accept certain presentations are by invitation, others they invite proposals. So they want to, and they're not going to present the same material over and over. So they want to get, they very much want input from people as to what they would like to get out of a conference. So I would just suggest that, Grace. And also, if you think you might present something, or if you know someone who might present something, they would really welcome that too. Carol Grayshaw, Grayshhaw, is the person at We Can Serve PA who puts together these conferences, and she's really good to work with.
Good. Are most of the people who attend the EAC conferences, are they urban and suburban, or is there a big rural contingent?
Right. So it depends if it's statewide or not.
Okay. Got it. All right.
Good.
Thank you.
Yeah.
Nice dialogue there. All right, so we're going to go into I'll go into the presentation for the day. So here's the basics review of, I'm just going to go through the presentations that we had this year. Just go through the minimal technology updates that were for 2023, and go through new stations and active stations. And then the bulk of it, I'm going to go through some examples of continuous data streams just to kind of tune in and discuss and just sort of touch on, the complexity and subtlety of the continuous data, and the importance of quality control, doing cross checks and, making sure you're really understanding what you're seeing and that the data are accurately reflecting conditions. I'm going to do summaries of 2023 data, the continuous data, and then summaries of the snapshot data that different groups did across the basin. And then hopefully we'll have time to talk some about 2024. Okay, so last January, we sort of planned, and as Ian mentioned, this was the start of the local policy and practice work group. We were called it a focus group then. We've changed to the term work group now. I think we've made a lot of progress there. Pete from Valley Forge TU then talked in February about the salt pollution in the Valley Creek watershed. Then Alan from Musconetcong Watershed Association talked about forming a watershed council, all the logistics and dynamics of that. April and May were water temperature topics, science of water temperature by John, and then I talked about monitoring and data usage. And then in June, Krista talked about using depth data and converting to flow and using it along with USGS data. And then in the summer, we had comprehensive updates, a full presentation from the work group. And then in August, Megan did a nice presentation on the urban stream syndrome specific to southeastern PA. She's gotten a lot of views on the video of hers. And then John talked about the science of salt pollution in September. And then I followed that up with monitoring of salt. And then last month we had the student presentations, which have had a lot of views as well, which has been good. And then here we are today. Some technology updates. Shannon's at the American Geophysical Union conference this week, and she's got multiple things going on there. So I'm kind of winging it here with some of the specifics, but she was doing mayfly upgrades throughout the year from the 0.5B to version 1 or 1.1. you can see the details of these newer mayfly boards, as I think most people know, on EnviroDIY. Also upgrading stations that needed new cell boards, upgrading those. As we know, 2G is disappearing, and basically as it disappears or as stations need to be upgraded for whatever reason, Shannon's been upgrading to this EnviroDIY designed LTE board. New Hydros 21 CTD sensor was also really brought into the fold this year. The pressure transducer is more protected. There's a quicker temperature response. And as I think folks who have these sensors know, the screw heads now are on the underside of the sensor. And you're just cleaning those accordingly. Those sensors seem to have been working fine. As I mentioned, the Campbell ClaraView turbidity sensor is the new turbidity sensor by Campbell. Shannon has indicated that it is performing well so far. It's less prone to fouling. It has a much shorter field of vision, and it points down as opposed to out into the water column. And then a number of new stations, which I'll mention in a slide or two, are receiving the version 1.1 Mayfly and the EnviroDIY LTE board. So folks that built their stations this year and deployed them all have those features. 19 new stations went out in 2023. Grace, Deer Park put a number of them in. Broadhead Watershed Association, Aquashickle, Pahopco, Marsh Creek, Jim Moore with Marsh Creek, working with Megan Fork and others, has deployed a number of stations throughout the Marsh Creek watershed. Dave Manning with the Valley Creek Restoration Partnership built one for Krabby Creek. So a number of new stations going out. Very coarse number here, over 130 that are active right now. Red does not necessarily mean inactive. There's a number of red stations out there, red meaning any number of things, but some of these red stations are just not transmitting to the portal, but may still be collecting data. Red may also mean that a station was relocated, in which case the data will not go away. It'll just be there, still reside there, but the site will be indicated as red. Other reasons that a site might be red: no cell transmission, but still collecting data, as I mentioned. The station may just not be functional. And as I mentioned, the station may have either been relocated or simply removed. Okay, so I'm going to go through just touch on some example data streams, continuous data streams, just to sort of get us to tune in at the end of the year here into the complexity, the subtlety of some of these data streams, and the importance of QC to kind of confirm what we're seeing out there. So really questions about whether the data are real or are error. That's a big question with any data, especially continuous data. Importance of quality control. And then in support of quality control, in support of, really understanding the data accuracy, communicating, dialoguing with, folks who are working with the data that you're working with, or folks that, may know, Shannon is a great resource, other folks at Stroud, myself, plenty of other folks. Steve Tricarico and I were talking today about one of the slides that I put in here, and he did a deep dive and figured some stuff out, which I included here. Maybe we'll expand on this in the February meeting, dive a little deeper into actual just data patterns, maybe get Shannon involved. We'll see how that goes. Okay, so this is your typical depth conductivity response. I think most people who are attending today, other than super new folks, know this. Depth goes up, standard pattern, general pattern, depth goes up, conductivity goes down. Runoff is generally, often, dilute in ions. So when there's large pulses of surface water runoff into the stream, it will dilute the ions in the stream and cause a dip in conductivity, and depth goes down and conductivity goes back up. Winter salt flushes. We had less of those last winter. We'll see what happens this winter. But those can be variable. As we see here, this is one site that is pretty contaminated. You can see here, depth goes up and it's sort of an initial flush of salt from road surfaces. Depth continues to go up, and then after that salt is flushed, then it returns to sort of more of a normal dilution pattern. And then it kind of recovers as depth goes down, conductivity goes back up, but then you get more water coming in due to rain or whatever else, presumably rain, I guess. And then here, another salt flush of sorts, and again, the same types of patterns. Here's kind of a secondary kind of pulse that comes in there. Who knows what that's about? It's not going to tell you everything. Kind of just going to give you leads on stuff. Again, here to that end, we have this situation, kind of a normal salt flush right at the beginning when that water runs off and it immediately carries the salt in. But then we've got here where it's almost like this was a rain event, which caused immediate dilution, but then there's a spike here, several thousand units, for a very short period of time that happens. So, who knows what that was? Was it, a salt pile or some other, flush of, from some effluent or something, or, it's hard to say. But those types of random miscellaneous spikes are not super uncommon. So here we're looking at Ridley Creek. This station is just below a treatment plant, and we see this oftentimes with treatment plants with the effluents where there's a regular kind of up and down pattern in the different parameters. This is presumably from the treatment plant, but whenever we see patterns like this, it's always good to kind of confirm the reality of it with on-site quality control checks with calibrated handheld meters. This is sort of getting at the point about using the data in a situation where you've got multiple stations on a stream. So this is an upstream downstream situation where black is downstream, black is upstream, green is downstream conductivity. And you can see that there appears to be something coming in here between the two stations. We have these two humps here. Now, as we know, the monitor situation, they're on different axes, but there's still enough going on here to show that seems to be something happening between the stations. And that's the idea of using multiple stations, being able to sort of, kind of dive deeper on sources of contaminants. Here's another situation on the Bashakill with, actually, I think I got these labeled wrong here. Green is upstream, black is downstream. So it appears as if there's something coming in between the two. There's a dilution effect here, but in the downstream, there's spikes happening. Here's a situation. These are non-winter spikes. Okay. You can see with almost every depth increase, there's some level of conductivity spiking happening. This is in the Broadhead watershed. This is definitely a situation where it would make sense to confirm accuracy with cross checks. It's tough though, as we know, when you get into looking at specifics of a stream, these types of dynamics, these spikes are quick. So getting out there during a spike to confirm it's real can be tough. You can certainly put out additional continuous sensors alongside the one that's existing to confirm that. And Shannon we have supported groups in doing that. Shannon has done this recently at one of the Tocconie Frankfurt stations to confirm these types of spikes. Here's another one. Non-winter spikes occurring somewhat associated with depth increases, but not necessarily. You can see here a depth increase, and then as it comes down, there's a spike. So there are some urban areas upstream of these of this station. So, you know, it's possible that there's something coming in there. But again, you want to be careful about this stuff, and you dive deeper into this, and it really brings up the importance of really making sure to make sure that you're really understanding what you're looking at, and doing that by using your hand cross checks or other methods to really make sure. Abrupt patterns. There's lots of abrupt patterns you'll see. This is one I mentioned that Steve and I were kind of diving into. I noted one, that there's a spike here. This is non-winter. This was in June, and there's a spike here. So that was suspicious. Not a huge spike, but it's there nonetheless. Here's another one. This is non-winter, so there's something happening there. And then I noted this sort of pattern here with these plateaus and up and down of the depth, and some of these kind of little bit kind of jinkety-janked conductivity readings here. Again, emphasizing quality control, but is this a real influence? Is this some sort of sensor issue? Steve dove into it a little more and did note that there can be a relationship of temperature with very small depth changes. So you see here it's sort of mirroring depth and some of the temperature readings in green here. However, what we also note is, look at right here, you know, here in about June 9 or so, where it starts getting really a lot wackier looking. You know, so what's that about? Is that just sort of a sensor issue? Is there actually something happening with depth variations? It's not a major issue. You know, I would guess that conductivity, for instance, is still, you know, reading accurately, temperatures reading accurately, and these are very minor changes in depth. Nevertheless, you know, if you're trying to understand really what's going on with your station, with the sensor and the stream, you really want to just make sure to understand these types of variations as much as possible. So getting into temperature, is on Angelica Creek. It's a trout stream with summer, you know, warming issues, as do many of the trout streams in southeastern PA. The vast majority, I would say, are sort of in that threshold where they're exceeding this. This is a relatively low temperature. Trout can tolerate above this. It's just they get into this sort of stress threshold, and you can see that, you know, here in Angelica Creek, it was exceeding that 19 degrees for a good portion of the summer. So just another, you know, sort of your up and down temperature. It just gives you a really good insight into, you know, in this case, temperature and how it relates to some of these types of ecological thresholds. This would be hard to see if you didn't have continuous data. What we're looking at here is a sort of normal up and down daily temperature fluctuation, but then we get in here where we're in the summer, we're getting into the summer, and we're getting stormwater runoff from warm impervious surfaces, and we see these temperature spikes. See, every time, pretty much every time, there's a depth increase in the summer in this you know, urban watershed or suburban watershed, and you get this thermal spike. We'll go in here a little closer to look, and you can see Valley Creek is it's a very cool limestone stream. You can see most of the time it's well below. This is through summer. You know, this is the hot part of the summer. You can see most of the time it's throughout the day, it's well below this 19-degree threshold. And yet, when you have these storm surges, it's causing a very quick increase in temperature up to, this range of 25 degrees, where that quick increase is, that would definitely be expected to influence, trout stress hormones, for instance, and overall, vigor of the trout. Bigger trout have a harder time with that. So you could see it influencing, the whole, the community, influencing the breeder type fish and stuff like that. So moving on, just getting into a little more specifics on importance of quality control. You can see this is a much broader view of a situation where we're going from, June through November. And we see depth increases and corresponding conductivity decreases, but we see here a dramatic dip in conductivity, several hundred units drop, and then it just stays there. Now, seems to be a gradual decrease in depth, which you would not, when depth decreases, generally you expect conductivity to go up. Depth goes down, the ions are concentrating more. And you are coming into summer then, but this is sort of opposite of what you would really expect. And it happens right after a decline, after a dramatic decline. So, very suspicious. This is the type of situation where you want to get out there and check your station. And then we have an increase, a dramatic increase. What's that about? So a lot of this is pattern recognition. You're not necessarily going to be able to tell exactly what's going on, but when you see sort of abrupt changes like this, it's a red flag to, start thinking about what's going on, getting out there and checking the sensors, cleaning the sensors, cross-checking with calibrated handheld meters. Another situation in which you're having quite a bit of fluctuation here in conductivity. Sometimes these sensors go wacky and start fluctuating, like this. And it's not necessarily going to mean that the data are completely inaccurate, but, you just want to know. And this may be real. We're seeing a fluctuation in depth here. There are upstream influences in this situation, but it's so patterned that it seems like it's a situation where, again, you want to, you want to understand if those fluctuations are real or not. Okay, so again, just trying to touch on those data patterns and just wanting to emphasize that, going in and, going into the time series visualization tool, checking your data, zooming in on data, asking questions, thinking about, the reasons for things happening, and just keeping a tab on things, I think is really going to help in building understanding of the technology as well as the, the ecology of the situation. And there's a lot of people available who are interested and capable of, dialoguing about this type of stuff. So hopefully we can continue talking about this type of stuff and support one another in understanding what's happening out there. So what we have here, moving on to continuous data summaries. This is all the continuous data from all the stations for 2023. This is conductivity data, so all the continuous conductivity data summarized as average. Color-coded according to just non-natural lands. So this is non-natural lands. So you can see you're basically going from red down to more blue and green. I put in here this 300 microsiemen per centimeter threshold, which is a very coarse threshold for that is, in sort of eastern type streams, lower conductivity, naturally lower conductivity streams. just a coarse benchmark for protection of aquatic insects. And you can see it's probably a little more than half the streams, or half the sites, I should say, have average conductivity throughout the year that is above that 300 microsiemens per centimeter level. This is chloride data, so it's the conductivity data converted. It's the continuous conductivity data converted using the chloride conductivity rating curve. Same basic trend, because as we know, conductivity and chloride are usually pretty well correlated. And what we've got here is the EPA 230 level. You can see that's, you've got a few sites exceeding that. And then we've got the Canada, a few more exceeding that. And then we've got the 50, which is the point kind of along the lines of the 300 conductivity level that's, more protective. These are sort of, basing this on Ohio and Maryland recommendations that are, referred to this as hazard or stress type thresholds. We're seeing numbers that are even as low as 30 or 40 milligrams per liter that can be influential on certain organisms. So meaning influential on, the entire ecosystem, really. This is all years for trout. I was having some issues with database to get just 2023. Most years are going to be pretty closely correlated. This is all years for all the stations for water temperature. I'm going to frame it here in terms of trout habitat regarding the levels. So we've got 19 degrees or less as fully supportive. This is, I forgot to mention, this is July and August. This is summer water temperatures. There's summer water temperature, 60-day. And so, there's, what is that? Maybe a sixth of all the sites are fully supportive throughout the summer in terms of temperature for trout. 19 to 21 is sort of this stressful range that we've defined. About another 1/3 of sites, a quarter of sites. And then we see quite a few are in this non-sustaining range of, an average summer water temperature of above 21 degrees. Now, again, these are coarse. You can certainly have trout living in streams that are above 21 degrees, but, the research is saying that when you have the average, a long-term average, a summer average that's above this, it is really getting into the range of not being able to sustain trout populations indefinitely. So moving on to snapshots, about quarter after, so I think we're doing okay on time. These are the groups in the Delaware Basin that did salt snapshots, mostly in 2023, some in 2022. Broadhead, Angelica, Valley Forge, Tookonie, Tacony, Frankfurt, Little Lehigh Watershed Stewards, the Bucks County Master Watershed Stewards, along with the Neshaminy Watershed Association, Willistown and Darby Creek, the Musconetcong. They've been doing multiple snapshots throughout the year in different regions. They may do a presentation in 2024 about that process. Nature Conservancy in Delaware, the Westchester University and Stroud and Stewards team. And then a number of groups have been doing these outside the Delaware Basin. We've been consulting with Isaac Walton League and a number of the groups that they work with across the country and doing these snapshots. So here's the snapshot data from all those points collected across the Delaware Basin. So almost 500 sites. Up to, almost 2,000 microsiemens per centimeter as base flow conditions, and then down to, very low, forested low conductivity regions. You can see here, I put in that 300 microsiemen per centimeter level, and you can see the vast majority of, or the majority of sites in these snapshots across the DRB we're above this 300 microsiemens per centimeter level, similar to what we saw with the continuous data, even more so though, really. Chloride, these are actual chloride measurements in most cases. Some of the folks just did conductivity and converted conductivity to chloride, but most of these are actual chloride measurements using chloride strips. And you can see, here again, the majority of sites above 50, a third or a quarter, looks like probably a third of the sites in these snapshots above the 120 level recommended by Canada, and then a smaller number above the 230. Here is that same data, snapshot data organized by watershed. So we've got Angelica. These are just alphabetical order, but they kind of line up coincidentally, kind of in an upward trend here. So we've got Angelica with Broadhead as the lowest. Looks, the majority of Broadhead sites fall below the 300 level for conductivity. Neshaminy, more of a suburban area. Little Lehigh, again, suburban influence. Musconetcong, suburban stuff, as well as getting into more snow area, some more salt application presumably. Northern Delaware, very urban, suburban, kind of mall type area where a lot of these higher sites are appearing. TTF, Philadelphia, really getting up there. The highest, between these 25th and 75th quartiles. So the majority of the sites at TTF are the highest of the watershed sampled. And then we've got Valley Creek, again, a suburban watershed that's a lot of salt application. Darby Creek, suburban, a little more rural. And then Westchester, again, a suburban area with a pretty high variability here in Westchester. There's some, fairly forested and rural areas, and then there's some really heavily impacted, impervious areas right in the town of Westchester and nearby. The chloride data, same basic trends. Angelica and Broadhead both generally kind of falling below that 50 milligrams level. Some of these other ones hovering around there. Musconetcong getting into the range of, chronic contamination that's going to be impacting biology. Northern Delaware streams, there's a variety there. There's some in there that are, really, really hammered, really contaminated, and there's some in there that are pretty okay. TTF, again, way up there. Same basic trends as conductivity as we might expect. We mostly have outliers here that are above the 230 level, but nevertheless quite a few in there. And then, some ranging up to the 400 and 500 level here in Westchester. And keep in mind, these are sites that are just, these are chosen strategically, but it's a small portion of the streams that are out there. The more sites you can do, the more spatial resolution you get in terms of contamination. Westchester has the highest variability, and it also had almost double the number of sites of any of these other snapshots. There was 108 sites done in this snapshot. Okay, water temperature. Valley Forge, TU, Broadhead, and Angelica all did temperature snapshots. Here you can see a lot of exceedance of this cold water standard, this cold water threshold among all of them. Broadhead seems to have the most exceedances. There's a lot of trout streams up there. The majority of streams in that region are trout streams, and so this points to the need for preserving what's there and buckling down on continued support riparian forests, of this type of thing to preserve shade, preserve groundwater flow, so on and so forth. Just noting that these temperature snapshots are strategically done, at mid-afternoon in these hot summer days of July and August to get kind of these around these peak temperatures, daily temperatures. Just frame that same data with regard to a fishing context. Carol recently developed a one-pager for a fishing group in the Tunkhannock region and provided some of these types of standards. This isn't anything new. This is just, kind of the basic. You're really looking in this range, 19 up to 21 or so when you can fish, but you really want to be careful. Using barbless hooks, thicker line, netting fish, not taking photos, not taking them out of the water if you can help it, and then not fishing at all once you're getting above 21 degrees or 70 degrees Fahrenheit or so. Okay, so we've got a little time here to talk about 2024. Here's what we have right now. Work group and others have talked about this. I'm just going to roll through here and point out these possibilities. I encourage, it's possible we could do a survey. Let me know if you think, you can talk about it here today, if we think a survey would be helpful to determine what we want to do for 2024. People have strong opinions on that. I'd certainly like to hear. We certainly would like to hear. But this is just sort of a draft list. So again, January, possibly sort of diving a little deeper into, and revisiting station maintenance and troubleshooting, this type of thing. Possibly in February, diving deeper into, the actual data, looking at trends, understanding trends. March, it's proposed for Krista to do a EPA habitat assessment methods presentation. She uses those in a lot of different situations and thought it might be helpful to tune folks into that process. April, again, looking at possibly a water temperature presentation. Maybe we see about getting John to just do it again, same as last year. There's some other folks that we've been working with on temperature that might be good folks who are actively researching temperature topics. Maybe get them involved here. May, kind of doing a refresher on snapshots, how to do temperature, how to do salt, possibly bringing in other parameters. Recommending it would make sense in certain scenarios, limestone streams, to do alkalinity testing as well, use alkalinity strips. June, we're looking at a comprehensive update again from the work group. July, possibly on fluvial geomorphology, tying in depth data. August, maybe model my watershed, maybe an opportunity for someone to step up and volunteer. September, maybe Musconetcong, kind of talking about some of the stuff they've been doing. Carol and Krista were planning to talk to the DRBC about some of the stuff they've been doing, so maybe reporting on that. Maybe reviewing salt monitoring again in November. The student presentations seem to be well received this year, so we were thinking maybe we do that again in November, and then maybe a year-end summary again in December next year. But certainly open to suggestions. So I'm just going to leave it at that, and we'll go back to this, and I will leave it. I guess I can leave this open, and we'll just open it to questions. We've already had a few people check out, so here we are at 3:30, but we can certainly discuss if folks have ideas, suggestions about topics, about specific topics, or about maybe doing a survey or something like that to really poll the group on what people need, what people want, what people are interested, so on. Thoughts?
Dave, I had a specific question on one of your slides. You were showing noisy EC data, and it looks like you zoomed in and it looked like it was pretty obviously daily temperature cycles. Is that in fact what was causing the noise, or was it just a dirty sensor?
I don't know, Jim. I mean, that was kind of the point, was that I was just sort of, I just did, you know, took a couple hours and just kind of scanned sites and was just sort of finding sites that had things that were suspicious that I couldn't necessarily explain off the top of my head. I am not sure about that one. You know, as you know, sometimes these parameters get linked and they start mirroring one another. That's certainly a skill, or certainly a tool to use in terms of troubleshooting. If you see mirroring, then it's likely there's something going on. But so that's one approach. Also going out to, you know, actually check in person. Sometimes these things look like they should be sensor malfunction or sensor issues, and they turn out to be real. So I don't think
I assume where there was step changes of connectivity, that would certainly be a sensor issue and, well, you know, warrant checking with the handheld.
yes,
where it's
and you
at.
know, and then there's other things, as you know, Jim. You know, if there is something like that, you know, checking, you know, the sensor itself, you know, cleaning, that type of thing.
Oh, the other question I had, do we have any field data on the turbidity sensors with the wipers? I know that the newer ones actually have a wiper. I've never actually seen one, but do we have any actual field data that says it's really working or not?
Some folks have put out those Yosemite wipered sensors. The Campbell one that I mentioned, the ClaraView, the one that I mentioned, does not have a wiper. It just has a very short field of vision, and it has, like, I think it has the copper to prevent algae accumulation and such. And it points down, so it has there's less risk of you know, fouling by big objects, and you can also presumably protect it. Yosemite, I think, let's see, Krista, I think, has some Yosemitex out. I'm not sure. Shannon isn't here, so I can't remember. There's a few other folks that have put the Yosemite wipered ones out. That's a topic we could look into.
Mike,
For
Mike,
2024.
Yeah,
Mike
I was gonna say Mike Bullard. I'm pretty sure he has some that he's been experimenting with.
Right.
is it the
right.
Yosemite,
Mike had
Mike?
some.
Because he's here at this meeting. He said he had failures of a couple of them, but I don't remember which company it was.
Yes, we're using the Yosemite. They're fine. It's the
Oh,
power
okay,
supply
right.
that's being delivered
Sorry.
to them
Right.
is an issue right now,
Right.
and we're trying to
right, the
figure out.
power
So the
supply.
sensors are great. The problem is they're coming from China. So, and no, it's working perfectly, as perfectly as any of these turbidity sensors are going to work, because obviously the material going by them at any given day or hour during a storm is going to change radically. So it's really hard to get from turbidity to some sort of sediment rating curve. So if that's what you're really looking for, is some turbidity sensor that's going to return sediment in terms of, you know, milligrams per liter or something, that's going to be pretty tough, because you're going to need to be you really need to characterize what's flowing past that sensor during all sorts of different storm regimes. You
Yeah,
can't just convert directly from NTU to milligrams per liter for any of these. I
and
don't think.
presumably, if you're going to do that, Mike, you want to be strategic and have it lined up so that you're not just expecting to be collecting turbidity data for a long period of time, worried about keeping the sensors perfect. You want to try to get out there and get the data that you need in a relatively short period of time as possible, or at least get the curve established.
What's really interesting is if you are collecting data several times an hour, you actually, the timing becomes really important, and that timing is going to be a signature of where that sediment's actually coming from during that stormwater event. And if you've got good resolution of rainfall events upstream, you've actually got information there. You don't actually have to know how much sediment, but you can characterize where in the watershed it's coming from. Again, if you've got good resolution rainfall data as well to work with.
Cool. All right, so we've got turbidity as a possible topic that could go into the fluvial geomorphology section in July, maybe. Other thoughts?
I have a question. Do we have comprehensive chemistry of these rainfalls throughout where the stations are? What is in the rainfalls?
So you're talking about going out and getting grab samples during storm events, right, Grace?
Yeah. Or whether, I don't know if USGS does that or who does that. To factor in if some of these storms are bringing in undue amounts of whatever.
Have you done that with bacteria in yours? Because presumably there's loads of bacteria, loads more bacteria in your
We haven't done
situation.
any in the stream. We've just done it in the stream. No, we haven't done any of that. And my other question is, I've just been observing a couple of things along the swales and the ditches, the changing salt or no salt. Japanese knotweed can start out slowly, and then it's now, it seems that I don't know what is feeding it, if it really thrives on salt. So I know nothing about the biology of the plants, and there's a grass that is getting very pervasive, particularly along roadside runoffs, those little swales that go down into the culverts. And this is, and it's spreading, but it is very prevalent in this area. And then it's, of course, you see it on hillsides where there never was this grass. It's not an ugly grass. It's easy to pull out. A lot of people have talked about it. I forget the name of it, but I'm just wondering about if these are plants that really thrive or contribute to the soils, whatever chlorides or salts. I mean, there's some plants that thrive on salts, and how that would factor into what is going on in the little waterways, the big waterways too, obviously. But particularly in areas that are not denuded, that have these new grasses growing. And what's the deal? Are there comprehensive soil studies in all of these areas? It seems to me it's like every aspect would inform everything that we're dealing with. I mean,
Yeah, I mean, anyone feel free to speak up. I mean, I know Jim Moore has seen the proliferation of Phragmites in his region, presumably because of salt. And there's definitely studies out there that are, identifying similar things to what you're describing, Grace, of changing situations along roads in terms of vegetation because of salt, and showing changes in, soil biology as well as soil chemistry.
I think because it involves highway departments just whacking knotweed and leaving all the tops there. I don't know whether all of everything that's cut, it's just it's not collected. and it just rots there. And I just wonder whether that is perpetuating a cycle. I know nothing about that. I do know the best ways to suppress it and kill it, but you would have to be out there mowing 1 inch to the ground, getting rid of all of the leaves. But 5-foot things, it grows so high everywhere.
Knotweed. Anyone have
Yeah.
specific knowledge on knotweed? I mean, knotweed is one of those pioneer type, where it kind of takes hold in, looser soil, and you see it along on kind of, sandbar type areas and, islands
It's
and stuff like
everywhere.
that.
It's not,
obviously pretty pervasive.
But
it's,
Dave, I was going to comment on you mentioned the Phragmites, and we do have an active program with Dr. Megan Fork, and her student is doing a study. He's got a bunch of wells out in the Phragmites. So we are actively looking at the saltwater runoff from the turnpike. So that's an ongoing study. And I guess he'll be publishing it's a master's thesis, so I guess it'll get published sometime, which I'll share with you all.
That's great. Yeah, maybe he could
Great.
present that at one of the meetings or something.
Yeah, I'll talk to with Ben Langley. I'll talk to Megan and see if they want to present or when they're ready to. They haven't really looked at all the data yet. They're just slogging around in the Phragmites, and believe me, that's a chore.
Right.
I will talk to them about a possible presentation at one of our seminars here.
Cool. Great, Jim. Other suggestions, questions, ideas for presentations or from others? Okay. Well, we are approaching 15 minutes over time, so I guess we should probably finish up here. I will stop.
It's been a great year. I mean, the last presentation of the students, and just John Jackson's presentation.
Good.
My
Good.
interest in the municipal presentations, and although we haven't participated in that, is because we have ongoing relationships. Sometimes it dips to be very negative, sometimes it evens out. Given the nature of our town boards, and that it seems I'd be very interested even in the rough draft of that, because I think it has to be a new, well, who am I to say? I think nuance, because there's such a vast need for different approaches,
Right.
and from hat in hand to moderately cocky, depending upon who receives it. And yeah, so it's like community involvement. In our area, we were going to do a little handbook, community involvement for dummies. No, just kidding. But so many people have no experience
Right.
in expressing their concerns before boards. And so we never want to just have the know-it-alls, the people who are in the loop, being the presenters or expressing things. So
Yeah.
enough said. Okay.
No,
a
great
great
points.
year.
Great
Very
points, Grace.
helpful.
Thank you. Thank you. Appreciate that. Really nice points. All right, all. Well, thanks. And most people have left at this point. We're still recording. But Thanks, everyone, and be in touch, and happy holidays, happy new year.